Afternoon, everyone. Thanks for sticking it out. I think we're getting to that last stage, so we'll try to keep this crisp. I'm Swapna Yasarapu with Azure Storage, and I think you've all probably met.
This is Shruti Sethi here again with Azure Storage, Microsoft.
And we're going to talk about sustainability opportunities for cloud storage in particular. So the agenda for today is to talk about the state of the carbon emissions and carbon goals in the industry, specifically about the targets that Microsoft has set forward as well, and I think we covered that in a brief amount in the previous presentation, and then spend the time in diving into what the major contributors are for carbon in the storage infrastructure and what are the opportunities for us to work those down. So just kind of diving into this, right? And you've probably seen different versions of this data this afternoon specifically. But if we look at the ICT industry's contribution to carbon emission, it's expected to grow by 4 times in the next 2 decades. So quadruple, 4x. And we're going to start from a base, which is about 3.6% to be 14% expected. And if we look at it in comparative terms, it's going to be as big as or bigger than the agriculture field and the commercial and residential. And if we think of transportation, which is known for being very carbon heavy, will be almost half as big as where transportation is at. So you don't see that in the data set today, how ICT sits, because it's actually broken down into its subsegments on the right side of the pie chart. But we're on our way, if left unchecked, right, to be a very big portion of carbon in the planet. So what's the opportunity from a market perspective, right? So this is a study from Fortune Business Insights that talks about the market projections for green data center. And it's expected to grow by 3.5x, so from about 60 to about 200 billion. And as a portion or a percentage of the overall data center market, it's actually increasing in its share. So it's going from being about 1/4 today expected to be about 1/3 if we fast forward in this time horizon. So there's actually opportunity in terms of reducing the carbon footprint, and there's actually economics that can actually also be an opportunity for all of us, right? So we can do good and be good, so to speak, if we do this right. So from Microsoft's perspective, and I think this was discussed earlier, we do have sustainability goals. Broadly speaking, for 2030, we would want to be carbon negative. That is, we want to offset or remove more carbon from the atmosphere than what we actually push in to the atmosphere. We want to be water positive, which means we want to replenish more water than what we actually consume globally, and then get to a state of zero state, which means we are actually reducing, reusing, recycling to drive to no waste direct to landfill. And there were discussions earlier in the afternoon today in another presentation where one of our colleagues actually talked about today the amount of waste we produce is essentially a stack of 757s, right? Like it's humongous in how much we actually produce. So we have work to do clearly, but we also have an overarching goal for 2050, which is to get to remove an equivalent amount of carbon that Microsoft has emitted since its inception, which was in 1975. So that's an overarching goal for 2050. So kind of take it back. So with that in mind, I'll pass it to Shruti, who's going to deep dive into the sources of carbon as it pertains to storage and some calls to action.
So I'll take just a little bit to actually level set, because some of these carbon emission categories are defined differently when you are a different member of the value chain. So these are essentially from a cloud provider's perspective of the value chain. So when I'm referring to like scope 1, I'm thinking of burn, like emissions that are directly related to fuel combustion, while scope 2 is related to buy, and I say buy because that's related to power or energy that is bought in order to run the systems. And scope 3, I just write beyond over there, essentially because that scope 3 includes a lot many buckets, which includes the manufacturing of the hardware IT equipments, but it also includes the flight that an employee took to OCP Summit. On the right side, the column on the right side, though, you see subcategory of interest that is mentioned. And for scope 2, so for scope 3, that's the last row, it mentions embodied carbon. And that's because we are highlighting that because that's a major chunk contributor. Embodied carbon is everything from mining of the minerals to manufacturing of device, installing the device, and also think of the end of life of the device, not considering the use phase of the device. So embodied carbon does end up being a big chunk. And the other thing mentioned in row 2 on the rightmost is operational carbon that I will refer to, which is the carbon related to the power or energy usage. So these two, operational carbon and embodied carbon, we'll be using further in our discussion. Okay, so this is Microsoft's 2022, previous year's carbon emissions. And if you see, categorized in the same scope 1, scope 2, and scope 3 that we just defined, scope 3 ends up being the largest contributor over here, which includes embodied carbon as a major chunk, followed by scope 2, which is roughly over 1/4. And then scope 1 is a thin sliver. So for today's discussion, I'll ignore scope 1 and go ahead with the other two categories. Okay. So let's see what's happening with storage, because after all, our topic was opportunities in cloud storage. So what's happening with storage? So this is from some IDC data. The top right graph actually shows how the data sphere is becoming really large and is set to become about 175 zettabytes on 2025. So it's right here. And that's obviously encouraging more storage infrastructure to be installed and shipped. So the lower graph on the right shows storage media that is about 5 zettabytes that are going to be shipped in 2025. So that is compound growth of that is about 17%. With this growth in storage infrastructure that is happening, obviously there is growth in the carbon that storage is contributing. So we looked at what we said we will consider as the components of storage carbon. I want to point them out here again. So on the left, you see we have mentioned embodied carbon, and on the right, the operational carbon. So embodied carbon, again, related to everything from mining, manufacturing, installing the device. Embodied carbon is essentially the power usage phase. So think of, we need to sort of have an equation to bring both of these together. That framework to be able to look at both of these together is, I'll give it a comparison of, say, TCO on the left, because that is something that we are completely familiar with. We look at upfront cost and we add operational cost. Similarly, we need to build a framework for carbon that would be embodied carbon, similar to upfront cost, and operational carbon, similar to operational cost. But that's not it. This entire thing, per unit ability, and I say per unit ability in the sense that maybe that particular infrastructure is storage, and that ability is going to be capacity. You might have a case where the ability is maybe some other unit of performance, in which case it might be per unit nodes, per unit VM, per unit, whatever is your measurement of performance. So we looked at main contributors for carbon, for storage, and we looked at we need to build a framework in order to see the total impact. Now let's dive into some of the device categories used in storage infrastructure. So before I go into the device categories, this will be a qualitative comparison of these. And essentially, the reason it is qualitative is there are still limitations on how standardized LCA processes are and how different carbon databases, how standardized different carbon databases are, which is also why the exchange of carbon information between value chain is not that prevalent yet. But the attempt here is to run a similar LCA or carbon impact analysis on all of these device categories. Okay. So first, okay, let me hold here. First, let's look at the first contributor we discussed, that is the embodied carbon for storage infrastructure, right? The embodied carbon certainly depends upon how much of silicon or precious metals, etc., are going into that particular device type. On the other hand, if we look at operational carbon over here, we might see that a different device category, say, for example, processors, are higher for the operational carbon. So we discussed that we need to look at these two legs together in order to understand what is the carbon impact. But I'm actually going to point out that there is a third aspect that we need to see. And that is what percentage of global storage fleet is actually comprised of each of these device categories. For example, one of the category might have a lower or medium embodied carbon, again, lower or medium operational carbon, but maybe it is deployed at a very large extent. So the percentage of storage, global storage fleet is very high. So we need to be cognizant of the fact that its total impact is going to be high. Another device category might actually have a high individual embodied storage or embodied carbon or operational carbon impact. However, maybe it actually comprises of a very small percentage in the fleet, which means its net impact is going to be lower. So we need to take all of these three legs into the equation in order to understand where do we prioritize our efforts. Now, this is still not a complete picture. If you actually start taking into account maybe what is the lifespan of each of these device categories, then you're adding one more component to the equation. Okay. I will jump a little bit and maybe see what are some of the carbon reduction approaches. So first, we'll discuss for embodied carbon again. And I wanted to bring attention to three main approaches. The very first one, increasing the device lifespan. For each of these approaches, I'll also point out what could be tricky. So increasing the lifespan, all good, will be very good in terms of carbon. However, the device still needs to satisfy other key metrics. If I deployed my device for longer, but the device now uses a lot more power than a latest generation device, I may not have a net carbon reduction. So we need to be cognizant of the other key metrics of the device. The next thing, circularity, that is repeatedly mentioned, is basically to enable the reuse. Now, particularly because we are focused on storage in this presentation, one key thing that holds back in storage reuse is confidently and securely wiping the data, the customer data, from the drives. And the last approach, which is recycle enablement, so enabling modularization or basically recycle of the device or subcomponents of the device. Okay, so we looked at three for the embodied carbon. I'll highlight three for operational carbon. And these should seem like steps that can build on each other. The very first approach, or the first step, is getting better visibility of the power and telemetry of the devices. And there is one work stream in OCP sustainability that's already trying to work towards better telemetry. The second one is now building on that and looking at what low power states can be utilized in the data center. Now, traditionally, data center devices have been thought of as low power states are not accepted. They are always on, ready to go. But we need to sort of change the innovative approach over there in order to incorporate what low power states are possible in these devices. And the third one, which I think most of us have always concentrated on, is using the devices most efficiently when they are in the active state. Okay. With these opportunities for embodied and operational carbon, there is one other leg of opportunities that we would like to highlight so everyone can keep in mind. And that's completely tangential, but keeping a lookout for new storage media that has lower carbon impact. There are two examples here. The first one being silica, which is glass-based, so data stored on glass platters. And the second one being DNA, or molecular storage, so data stored in the form of biological oligos. Such storage media could have like a lower carbon impact due to either the material or the media is recyclable easily. Maybe the glass plates can be recycled, or the stored time, that is when there are no accesses going on. During the stored time, the media needs no power. So I do not need to power it while the data has already been written and just sitting there. Or maybe the life cycle of the media is extremely long. So think about, I don't know, I'll say molecular or DNA over here. If the life cycle is extremely long and my refresh cycles are very low, that again saves me carbon. Okay, with that, I would like to wrap up this discussion. So just bringing attention to a couple of points. With cloud storage that is rapidly growing right now, A, we need to standardize and build a framework around the metrics. B, design for the reduced embodied carbon and operational carbon. Just like, remember these two words, reduce embodied carbon, operational carbon. And lastly, keep a lookout for absolutely new media that could have a low carbon impact. And down below, please join us for OCP sustainability. Thank you so much. There is the direct link.
May I ask a question? Is there any discussion about carbon avoidance? Meaning if you depreciate that embedded carbon, and you continue to use it longer, or you reuse it, is there any yield back to the equation?
So when you say, is there any discussion? My answer would be yes. There is discussion for it. Do we, and now I'm actually pointing to even discussions that are within OCP members. There is certainly discussion about when there is reuse or recycle or longer deployment, how do you actually factor in the carbon accounting? But I don't think there is a formal sort of guideline yet, but that is certainly something that, at least in OCP, we would want to work on. And Ari is vigorously nodding. So it's something that we do want to work on. And if you're interested, please join us.
Yeah, I'll just add a comment there for circularity, for reusing storage devices. We are working at Seagate. We're working with consultants on some kind of carbon accounting where you get carbon credits. That's probably next year, but that's certainly something we're working on, and we're collaborating with Shruti and OCP closely with that.